It's like I don't care about nothing, man. Yeah. Oh,
What's going on now? The last video was through pages 1 and 2. Today's video is for page 3. Now this one's going to go over a lot more of the theorems that we'll need. So for instance, like vertical angles theorem, where we know that the angles across from each other are going to be congruent. Another one where we have linear pair postulate, where you have two angles, which makes our pair, add up to 180. So we'll go through each of those, and you'll also see some that are going to be a little tricky for you right now. That's because later on in the unit we will go over them a lot more thoroughly. So don't worry if you see some that you're a little iffy on at the end of the video. So now this one starts off with page 3. I'm going to look at the top 5 first. I'm going to fill in the blanks, and then I am going to draw a picture of how we could represent each of them to have a little bit more visual with it too. So I will do that in just a second. So as promised, here is the stuff that you're supposed to fill in. Now, keep in mind, I do want you to pause it, write them, and then listen. So for the linear pair postulate, if two positive angles form a linear pair, their sum is 180. So if you don't remember what a linear pair looks like, it's going to basically form a line, and it's going to have a pair of angles. So hence linear pair. So over here, I drew a line and then made it so it has two angles. And if I added those angles together, it would equal 180 degrees. Next, over here, we have vertical angles theorem. If two angles are vertical angles, then they are congruent. So if you ever see two lines crossing, basically forming an X, each angle that's across from each other would be vertical and equal to each other. So this one would be equal to each other, and on each side would also be equal to each other. So these ones go together, these ones go together. They are congruent. Next, you have congruent complements theorem. If A and B are complements of the same angle, then they are congruent. So complement means they have to add up to 90. So the idea is, if I said that one angle, we'll call it angle C, is 50 degrees, then both A and B would have to be 40. Because A and B are supposed to be congruent, because they are, each of those would be the complement of that. Now right next to it, it says supplements. The only difference with this one is, if I had a supplement, means they have to add up to 180. So let's say if I said angle C is 130 degrees, that means both angle A and B would have to be 50, because both of those angles are supposed to be the supplement to this angle. So it would have to add up to 180. And then we have the right angles theorem. Now, something that a lot of people got wrong on the test. This right here is not a right angle right now. The reason being is because there is not a box already drawn into it. So the box has to already be there. You cannot just add it, because if the box is not there, it could have been 89.9. It could have been super close. But until we see that box, we do not know for sure. So that was a common misconception on the last test. So next, I'm going to do these 4 here. With these, we are actually going to learn more about these later on in the packet, so it will make a lot more sense later, but I still would like to go ahead and fill them in. So I will fill them in and then go over them. So as promised, I have it now in front of you. So again, these won't make too much sense because I haven't gone over it yet. We'll go over these more specifically later in the packet, but I still wanted you to have them written down. If 2 parallel lines are cut by a transversal, then they are congruent. So if 2, and then we wanted to give the converse statement. So a converse statement, remember from the video before, is when we switch the order of the if-then statement. So if 2 lines are cut by a transversal and the corresponding angles are congruent, then they are parallel. So let me just draw you something here. I'll kind of draw what corresponding angles actually are. So parallel lines are lines that are never going to touch. A transversal is a line that cuts through parallel lines, so this would be a transversal. So every time that you see this from now on, you know a line that goes through parallel lines is a transversal. Well, corresponding angles would be like here and here. They have to be in the same spot on the other parallel line. So this one was above the parallel line on the right side of the transversal. Same thing for this one. So it was up above this parallel line on the right side of the transversal. So we'll go over this more later on though. The next one we have is alternate interior angles theorem. So if 2 parallel lines are cut by a transversal, then they are congruent. So if I were to draw this, so again, parallel lines, a transversal, then our alternate interior angles. Interior means that they have to be inside of the parallel lines. So like right there, and if it's alternate, they have to be on alternate sides of the transversal. So, and then now the converse statement of that was if 2 lines are cut by a transversal and the alternate interior angles are congruent, then they are parallel. So that one was alternate interior. So the next one was alternate exterior. So if interior was inside the parallel lines, then hopefully you can guess that this means that it is outside of the parallel lines. So for instance, if I went here, it's exterior because it's outside these parallel lines. And down here, alternate side of the transversal, but also still outside of the parallel lines. So they are going to be congruent. And now the converse statement where we just switch it if 2 lines are cut by a transversal and the alternate exterior angles are congruent, then they are parallel. Then the last one out of these 4, which again will make more sense later on into the packet, consecutive angles theorem. Consecutive angles are going to be ones that are on the same side of the transversal. So like consecutive interior, for instance, would be inside the parallel lines, and they would both be on whatever side we're talking about. So I did it on the right side. So that would be an example of consecutive angles. So these ones are the ones that change it up on us. If 2 parallel lines are cut by a transversal, the interior/exterior angles on the same side of the transversal are then supplementary. So supplementary, again, means that they add to 180. Now, the converse of that statement, where we just flip them, if 2 lines are cut by a transversal and the interior/exterior angles on the same side of the transversal are supplementary, then they are parallel. So again, if this didn't make as much sense, sorry I didn't notice I didn't have this on there. If it didn't make that much sense, don't worry about that because we're going to do a lot more practice with these angles in a little bit. Okay, so the last one, we have two more. This is stuff that we've actually kind of gone over before. We have perpendicular bisector theorem and perpendicular transversal theorem. So perpendicular lines have to meet and make a 90-degree angle. Bisector, cut in half, stuff like that. Now I'm going to go ahead and fill them in and then we'll go over it just like we did on the other ones. And now they are filled in. So perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And then the converse is we just switch them. If a point is equidistant from the endpoints of the segment, then it's a perpendicular bisector. So if I wanted to see a picture of a perpendicular bisector, we would have two lines that are going to cross, and they would form a right angle because it is perpendicular. So perpendicular tells us that it's going to be 90 degrees. And since it's a bisector, then it would have equal values. So whenever you see a dash shows that they're equal. So a dash shows they are equal. So that's something you would want to know, that if you ever see the dashes, so these both have one dash, so I know they are equal to each other. And last but not least, we have the perpendicular transversal theorem. So in a plane, if a line is perpendicular to one of the two parallel lines, then it's perpendicular to the other line also. So perpendicular transversal theorem, corollary, if two lines are both perpendicular to a transversal, then they are parallel. So here is the idea. So if I go to draw this, I'm going to move it over slightly. If I had two parallel lines, and the line going through is supposed to be perpendicular, so it makes a 90-degree angle here, it would also be making one here. So technically, every single one of these boxes would be a right angle. So if I have parallel lines, and one way that we'll know that they're parallel is if you see a little filled in triangle on them. So you'll see more examples later like that, but if you have a right angle, they both have a right angle. So that's the end of the video. Hopefully now you have a little bit better understanding on each of them. Now, one of the main things that you should know now, because it was a big mistake on the test.
How do I reach these keys?
If you see something that looks like an L, if it does not already have a box, we cannot assume it's a right angle. A right angle has to already have that box in there. Just because you draw it in there does not make it a right angle. If you saw that, that could be 89.9 degrees. We do not know for sure. But that is, I would say, the thing that you want to make sure you take from this video, because I was surprised at how many people got that one incorrect on the test.